Hello, this is Lisa. In this video, we're going to talk about linear equations. A linear equation in one variable can be written in the form ax plus b equals c, where a, b, and c are real numbers and a is not 0. If a were 0, then we would lose our variable, and we don't want that to happen. Examples of some linear equations are 3x plus 2 equals 8. 1/2 x minus 5 equals 11. Or if the b value is 0, we would have 3x equals 6. Examples of some nonlinear equations are the square root of x equals 4. The square root makes it not linear. 1 over x equals 10. We can have a fraction in the coefficient or the number with the variable, but we cannot have the variable in the denominator. That's what makes that equation nonlinear. And another example of a nonlinear equation would be when we have an exponent on our variable. 3x squared minus 5x equals 2 is not linear. The solutions to a linear equation are numbers that make the equation true. For the equations that we're going to be doing today, linear equations will have just one number that could possibly make it true. Determine if the given number is a solution to the equation. So in this particular problem, they're asking us, is 17 a solution to my equation? If I replace x with 17, does it make the equation true? Is 17 minus 3, is that equal to 14? 17 minus 3 is 14. Equals 14. Yes, it does. 17 is a solution to my equation. In equation number 2, they are asking us, is 3 a solution to my equation? I substitute 3 in for x. 5 plus 3. Is that equal to 7? 8 is not equal to 7. So my answer here, no, this one is not linear. The addition principle of equality says that if a, b, and c represent real numbers, then a equal b and a plus c equals b plus c are equivalent. In other words, you can add the same amount to both sides of the equation without changing its solution sign. Now, I've put here you can add or subtract the same amount from both sides. Okay, addition and subtraction go together here. I'm going to do a couple of examples. X minus 3 equals 14. The first thing I want you to recognize is that equal sign divides my equation into two sides, what's on the left and what's on the right of that equal sign or that line. Now, I only have one x in my equation. I want to get that by itself. That's always our goal, get the x by itself. So here I have x minus 3. I'm going to add 3. And whatever I do on the left, I have to do the same thing on the right because I want to keep them equal. Negative 3 plus 3 is 0. So what I have now, x plus 0 is x equals 14 plus 3, or 17. And there's the solution to my equation, x equals 17. In MyLabs Plus, oftentimes they just put set braces, and they want you just to write your answer as the number inside those set braces. So that's another way of writing that answer. Example number 2 says we have x plus 2 equals 11. Again, I'm going to divide along my equal sign. I have x plus 2. If I want to get the x by itself, I have to subtract 2. Whatever I do on the left, I do the same thing on the right. Plus 2 minus 2 is 0, so I'm left with x equals 11 minus 2, or 9. And there's my solution to example number 2. Example number 3. This time our x is on the other side of the equation. That's fine. We're just still trying to get the x by itself. X minus 2, I'm going to add 2. Whatever I do on the right, I have to do the same thing on the left. 5 plus 2 is 7, equals x. And minus 2 plus 2 is 0. So we have gotten the x by itself. Example number 4 is a little bit different. This time we have just one number and we have two terms that have x. I need to get my two x terms on the same side of the equation. In this one, I'm going to subtract 3x. Once on the left and once on the right. So same principle, we're still adding or subtracting an entire quantity to get it out of the way. So 3x minus 3x is 0, leaves me with 3 equals 4x minus 3x is 1x. 1 times anything is that same thing, so this is the same as writing x. 3 equals x, and that's our solution. And that concludes this video. Have a great day, everybody.